This is day 4 in our unit that's based on exponents and everything that has to do with exponents. In previous lessons, we learned how to solve exponential equations, such as these. And in previous lessons, we learned how to simplify exponential expressions, such as these. This is a review lesson, so we are going to go back and forth practicing both of these skills at the same time. So this lesson is about simplifying and solving exponential expressions and equations such as all of these. All right, let's get started. For problem number 1, when you're solving exponential equations, it's all about having bases that are the same. So one thing that I can do, as I look at these potential bases, I ask myself, what number could I use for the base on both sides and have it be the same number? So on the left-hand side, I see this 9, and I'm thinking to myself, well, I could write that as 3 squared. On the right-hand side, I'm seeing this 1/3, okay? Focus on that 3 again, because I already have a base 3 going. But I could write this fraction as 3 to the -1 power, and that would have the same value. So the only thing I haven't dealt with yet is this exponent right here, the x plus 1. For right now, I can just put that in parentheses and know that I'm going to wind up doing the distributive property in a minute. Anyway, if the bases are the same, that means the exponents have to be the same. Okay, so basically I can ignore the base 3 and go ahead and set these exponents equal to each other. So the 2 times x plus 1 should equal the -1. But I will go ahead and do the distributive property. So 2x plus 2 should equal this -1. And then I can just solve this like always. So subtract 2 from both sides, and that'll give me 2x is equal to -3. And then divide both sides by 2. Okay, so that's going to give me x equals -3/2. So that should be the answer to number 1. And that gives you a basic idea of how to solve exponential equations. All right, let's jump over to the other concept of simplifying. Now, we have to raise all this stuff to this power. So basically, you're just going to do this separately to each one of these 3 things. If I ignore all this stuff, I've got -5 squared. -5 squared is positive 25. Next, if I look at the n term, now I've got n to the 4th power squared. When you do a power to a power, you multiply. So this will be n to the 8th. And last, I look at the p. If I ignore all this stuff, I've just got p squared, so that'll just be p squared. Okay, so that would be number 2. Back to solving equations again. All right, look at problem number 3. I've got this weird decimal here, but my advice to you is turn that into a fraction. All right, 0.1 is the same thing as 1/10. And if you don't know that automatically, which you should, you can use your TI-30 to show you if you need this service. If you type in 0.1 in your calculator and toggle it, it will remind you that 0.1 is 10th. So what I can do is going with a base 10, so I've got 10 to the 2x plus 9 power still. But as I just saw, 0.1 can be written as 1/10. I've got a base 10 in both cases, so let's just keep going. So I've got 10 to the 2x plus 9 power, And this can be written as 10 to the negative 1 power. Now, if the bases are the same, the exponents will be the same, which means 2x plus 9 must equal negative 1. If I subtract 9 from both sides, that gives me 2x is equal to negative 10. And then if I divide both sides by 2, that's going to give me that x is negative 5. Okay, so that would be the answer to number 3. All right, let's jump back over to the simplify side and do number 4. A lot of kids have trouble with this. The main thing to watch out for is if you have a negative exponent on a fraction, you're going to wind up doing the reciprocal of this fraction. This entire fraction is going to wind up being turned upside down, and this will become a positive exponent. But we have some things to do before we get to that point. So for a minute, I want you to ignore this negative 2. Let's just simplify what's inside the parentheses first. Now, in a previous lesson, I taught you that if you have a variable with a negative exponent, that means that this expression is on the wrong side of the fraction. So this p to the negative 4th power is actually going to drop down like this and become p to the positive 4 power. Okay, so it's going to move. Now I can go ahead and simplify this. So this is going to become, let's see. Now that 3, there's no other coefficient, so that 3 is going to stay there. If you look at the n's, I've got n to the 5th in the top, n in the bottom. This n will cancel out one of those n's and leave n to the 4th power. Now, looking at the p's, I've got p squared and p to the 4th, all on the same level. I'm going to wind up adding these, so this is going to be p to the 6th power. So this would be your answer. Whoa, I almost forgot my own situation. Okay, so this is all simplified now on the inside. Okay, but what I almost forgot was I had modified this problem, of course, because there is a negative 2 on it. So let me not forget that. Now, as I mentioned a moment ago, the way you handle a negative exponent on a fraction is you do the reciprocal and make it a positive exponent. So I'm going to end up with a positive exponent after I do this. From negative 2 will become a positive 2. But to make that valid, I have to do the reciprocal. So I will now have 3p to the 6th power in the numerator, and I will now have n to the 4th power in the denominator. And then I'm still not finished because now I have to actually square everything. So remember that a regular number works different than variables and exponents. So if I square this 3 squared is 9, so that's going to be 9. But these variables I'm going to have to multiply. So this is going to be like p to the 12th power, and this is going to be n to the 8th power. So that would actually be the final answer to number 4. Okay, back to the solving equations side. All right, let's do number 5. To solve this equation, we need these bases to be the same. I can write 9 as a base 3, so I'm going to go with the 3. So that means I can leave this 3 to the 7x minus 3 power. But this 9 I will write as 3 squared. This 2x is still going to be there, but I will just, for a moment, I'm going to put it in parentheses. Okay? That means what I really have is 3 to the 7x minus 3 power equals 3 to the 4x power. Now, if the bases are the same, the exponents will be the same. So I can set these exponents equal to each other like this. 7x minus 3 should equal 4x. If I solve this, then that will give me my x value. I'm going to go ahead and subtract 7x from both sides, get those x's together. That'll leave me with negative 3 is equal to negative 3x. All right, if I now go ahead and divide by negative 3 on both sides, that's going to give me x equals 1. Okay, so that would be the answer to number 5. All right, back to the simplifying side. Whoa, what happened to number 6? Maybe it's straight under. Okay, not back to the simplifying side. Continuing with the solving equation side. Now, we'll have to be careful about this one because this is one of those cases where we will have to change both bases to another form to make this happen. The 16, you know that you could, you have two options on the 16. 16 can be written as 4 squared. 16 is also 2 to the 4th power. So I can rewrite 16 as a base 4 or a base 2. All right, now look at the 64. 64 can also be written in two ways. 64 can be written as 8 squared, but 64 can also be written as 4 to the 3rd power. But obviously I need the bases to be the same. So what base do these have in common? 16 can be written as a base 4, and 64 can also be written as a base 4. So we need to go with base 4. So that's what we're going to do. So we will write 16 as 4 to the 2nd power, and we will write 64 as 4 to the 3rd power. All right, so I've replaced these two things. Now in red, let me show the exponents that were already there. That existing x will still be there, so this is going to be 3x. This x plus 1 is still there. Going to wind up doing the distributive property. So basically what I have is 4 to the 3x power is equal to 4 to the 2x plus 2 power. If the bases are the same, then the exponents will be the same. So I can set these exponents equal to each other like this. 3x will equal 2x plus 2. So if I subtract 2x from both sides, that's going to give me x equals 2. So that is the answer to number 6. All right, number 7. Back to the simplify side. Okay, got to simplify some stuff here. Let's see, what do we want to do first? Let's go ahead and deal with this guy down here. See, this is being squared, so that means this is really going to be 9 x to the 6th power, multiply those, y squared. Okay, so I've rewritten that as this. Now, this is what we're going to do. Let's collect all of our terms together as best we can. Okay, so let's see. We've got 27 times 2, that's 54. All right, let's put that all together. We've got 9 times 3, that's 27. All right, so I dealt with that. Now, let's look at these x's. In the top, I've got x to the 18th power. And we've got this n also. Okay, so you know what? Let me go alphabetical. So there's n. I have x to the 18th power, and I have y to the 12th power. Okay, I'm just putting everything into one fraction. Now on the bottom, I don't have any n's, but I have p's. Okay, so I've got p to the negative 5 power. Now x's, I have x to the 6th and x, so that is x to the 7th. And then I have y squared, and I have y to the 6th. So together that makes y to the 8th. All right, so it's easier if you put everything into one fraction. Now, 54 and 27, I'm pretty sure that 27 goes into 54 twice. And in fact, I know that. So simplifying these, I'm just going to have 2. All right, so that's going to make a 2. The n is just sitting there. That's not going to go anywhere. This p to the negative 5th power. That negative exponent tells me that it is on the wrong side of the line. So I'm definitely going to move it up. So I'm going to have p to the positive 5 power now in the numerator. Okay, now dealing with those x's, I've got, looking at the x's here, 18 x's in the top, 7 x's in the bottom. These 7 x's are going to cancel out 7 of these x's, and that is going to leave x to the 11th power. You know, basically subtract. And with the y's, look at all those y's I've got. So these 8 y's in the bottom are going to cancel out 8 of the y's that are in the top, and that's going to leave behind 4 y's. So that's going to be y to the 4th power. Now, nothing is left in the bottom, and I don't need a 1 down here like I would if this were the numerator. So this is just going to be my final answer. Okay, it wasn't too bad, I hope. Now, number 8 must be over here on the solving equation side. All right, now look, I see this fraction. I know what I have to do with that. Now, I'm seeing a base 5 coming, all right, because 25 can be written. So I'm going to write 25 as 5 to the 2nd power. And so that's going to leave the x minus 4 sitting there like so. But now with this fraction, as you've seen previously, I can write 1/5 as 5 to the negative 1 power. And then I've got the 2x sitting there like so. So that means that basically what I have here is 5 to the, now I'm going to do a little distributive property here, so this will be 2x minus 8 power, and that's equal to 5 to the negative 2x power. If the bases are the same, the exponents will be the same. So I can set them equal to each other like so. 2x minus 8 should equal negative 2x. So I need to solve this by subtracting 2x from both sides. So that's going to give me negative 8 equals negative 4x. So it is time to divide both sides by negative 4 to get x by itself. Okay, so that is going to give me x equals positive 2. So that's how you do number 8. All right, number 9 must be over on the simplify side. So let's do that. Okay, if I were you, I would handle it this way. If you have a negative exponent, that lets you know that the expression is on the wrong side of the fraction. So I'm going to take this n to the negative 3 power and move it down and make n to the positive 3 power. So that is now officially moved. Then I can go ahead and write my answer. That 5 did not go anywhere, so it's still like that. Putting these together, that's going to make n to the 9th power. All right, I guess I didn't need to make it all crooked like that, but that's the answer. 5 over n to the 9th power. Let's look at number 10. Back to solving equations. I see the 6's, so base 6 is in my future. So this fraction, of course, I can write as 6 to the negative 1 power. And that equals 6 to the 3x minus 4 power. All right, well, that was pretty easy. If the bases are the same, the exponents are the same. So that means negative 1 will equal 3x minus 4. If I add 4 to both sides, I get 3 is equal to 3x. If I divide both sides by 3, I get x equals 1. Alright, so that is number 10. Time to simplify again. Let's go over to number 11. Here's number 11. Now, both of these have negative exponents, so that means both of these expressions are going to move to the other side of the line. The x is going to go down, and the y expression is going to go up. Notice that the 7 does not have a negative exponent, so the 7 is not going to go anywhere. Right? So the 7 will stay where it is. The y goes up and becomes y to the third power. The x goes down and becomes x to the positive 2 power. So that would be your answer, number 11. All right, let's look for number 12. Back to solving equations. Hopefully you do not need a calculator to know that 0.5 is the same thing as 1/2. But if you need a calculator, hey, do it. So 0.5 is 1/2. So looking at it that way, you see the base 2 happening. So I have 2 to the 3x power equals 2 to the negative 1 power. Once again, if the bases are the same, the exponents are the same. That means I can set them equal to each other like this. Got to get that x by itself, got to get rid of the 3. So I divide. So divide both sides by 3. Go ahead and just leave this as a fraction. Do not make a decimal. So that's going to give me x equals negative 1/3. So that is how you do number 12. Okay, what about number 13? Okay. If I were you, I would move anything with a negative exponent first. So this is going to go down. Alright, so I'm going to have p to the positive 4 power down here. So I moved that, so that's gone now. Okay, now looking at the rest of it. Now 8/6, you got to reduce this. Alright, they're both divisible by 2. So this will be 4/3 if I divide them both by 2. Now looking at the ends, this n is going to cancel out one of these ends, so that'll leave me with n squared. Alright, looking at these p's, alright, I'll just put these together, so that'll be p to the 6th power. And that's it. That's how you do number 13. Alright, number 14. Back to solving equations. We've got base 5 happening, so let's go with that. So that means I've got this 5 to the x plus 2 power, and but I can write 25 as 5 squared. So the x minus 2 that's already there is still going to be there, but I'm going to have to distribute. So this is going to give me 5 to the x plus 2 power, just keeping that. But then I'll have 5 to the 2x minus 4 power. If the bases are the same, the exponents are the same. So I can go ahead and set these equal to each other. Okay, this equals that. How do I solve this? Do the x's first. Let's subtract x from both sides. That gives me 2 equals x minus 4. Then we add 4 to both sides. So that will give me 6 equals x. Alright, that's number 14. What about number 15? Okay. There's a lot of different ways to do this problem. Here's one way. If I do this power to everything, I mean, the trickiest thing is what to do with the 4. But this is what I would do if I were you. For a moment, I'm just going to write this as 4 to the negative 3 power. All right, I'm just going to take this negative 3 and just stick it on the 4. With the variables, of course, I can multiply. All right, 2 times negative 3. So this would be b to the negative 6th power. All right, notice I do not multiply the 4. All right, because that's not an exponent. Now the c, I'm just going to stick this negative 3 power on there. So that's what I have so far. Now everything with a negative exponent, I'm going to drop down to the denominator. So this would be like having 1 over 4 to the 3rd power, b to the 6th power, c to the 3rd power. So this is almost the answer, but let's go ahead and do 4 to the 3rd power. So this will be 1 over 64 b to the 6th power, c to the 3rd power. So this would be your final answer. Okay? That's one way to do it. Look, just in case you care, the other way to do it is to, you see this negative power on the parentheses? If you wanted to, you could drop the entire parentheses to the bottom all at once. So you could do 4b squared c. Okay? You could, if a negative power means you're on the wrong side of the line and has to drop down, you could drop the whole thing down. And then you could do the powers. So still that would give you 64 b to the 6th power, c to the 3rd power. All right, either way you get the same thing. Okay, number 16. All right, I cannot write 8 as 4 and a power. So this is one of those where we're going to have to change both bases. So let's do that. If I have to change both bases, so I'm going to do something like this. 8 can be written as base 2. All right, 8 can be written as 2 to the 3rd power. Meanwhile, 4 can be written as 2 squared. All right, so now I've got the bases the same, so this is looking pretty good. Meanwhile, I will keep the x minus 5, and I will keep the 3x minus 3. Which means that what I have here is 2 to the 3x minus 15 power, all right, distributive property. And this is equal to 2 to the 6x minus 6 power. Again, distributive property. If the bases are the same, then the exponents will be the same. Which means 3x minus 15 is equal to 6x minus 6. So subtract 3x from both sides. So this will give me negative 15 is equal to 3x minus 6. All right, go ahead and add 6 to both sides. So that's going to make negative 9. So we have negative 9 equals 3x. And of course, we will divide both sides by 3. All right, so the answer is going to be negative 3 equals x. All right, so that's how you do number 16. All right, let's take a look at number 17. Number 17, we have a lot of negative exponents. Everything with a negative exponent has to move. Okay, so this b to the negative 2 power is going to go up. All right, this c to the negative 6 power, that's going to go down. This b to the negative 5 power, that's going to go down. Okay, so the 2 and the 6 didn't move, so they're going to still be there. The c to the 3rd power didn't move, so I'm going to leave that right where it is. All right, these are all the things that moved. So the b squared is going to come up here like that. The b to the 5th power is going to come down here like that. And the c to the sixth power is going to come down here like that. Alright, now I can go ahead and simplify everything. So, let's see. 2 over 6, that's going to reduce down to 1/3. These two b's are going to cancel out 2 of these b's and leave b to the 3rd power. These c's, I can just put them together and make c to the 9th power. And that's it. We have to keep the 1 up there because it's the only thing holding the numerator. So that's it. That's how you do number 17. Okay, back to solving equations. Let's take a look at number 18. Alright, looking at number 18, we've got, I see the 3 and then I see the 27. Both of these can be written as a base 3. Of course, 1/3 can be written as 3 to the -1 power. 27 can be written as 3 to the 3rd power. Alright, the existing exponent here I will keep, and I will wind up distributing. Okay, so that's going to give me 3 to the -1 power equals 3 to the 6x. Why did I put 9? I said 6 and said 9. I mean, I said 6 and wrote 9. So 3 times 2, so I got 6x minus 9. Now that the bases are the same, I know that these exponents will be the same. Meaning, -1 should equal 6x minus 9. Adding 9 to both sides gives me 8 equals 6x. Dividing both sides by 6 to get x by itself. And that's going to give me x equals, now I just have to reduce this, so this will be 4 over 3. Please no decimals. So that is how you do number 18. Okay, this video is getting kind of long, and I see I'm at the end of this page, so I'm probably going to end this video after this problem, but just so you know, there are actually more problems still to come, a bunch more problems. So I'm going to throw the rest of those problems in another video. So I guess I'll have a part 1 and a part 2. So let's go ahead and wrap up part 1 with number 19. So let's see, I see the negative exponent here. That tells me that this is going to drop down. Alright, here's like my invisible fraction line. But I also see y to the 0 power. Please understand that anything to the 0 power equals 1. So this has a value of 1, which I don't really need to write because I've already got a 5 there holding the place. So 5 times 1 is just 5. So this is essentially gone. Okay, so if I just recopy all this, what I have is, notice the 5 does not travel with the x. So the 5 is still there, and the x to the 3rd power is down here. And the y, poof, it became a 1, which I do not write down. So that is it for number 19. Alright, and that is it for this video. It's about 30 minutes, long enough for a video. We'll call this the end of part 1. But coming up, we're going to be simplifying a lot more stuff. Here's just a quick preview. We'll be doing this and this, a little of this, that. Okay, we'll also solve a few more equations. Okay, so these are the problems that will be in the next video. Alright, I hope this has been helpful to you. If so, a like is always appreciated, and I will see you on the next video.